Assalamualaikum warahmatullahi wabarakatuh. Now, my group members want to present our PPL project for Engineering Mathematics 2, DAC 12403. We are from Section 2, Group 13. Our lecturer's name is Puan Nuraim binti Ahmad Nordin. Before we start our presentation, let us to introduce ourselves. Before we start our presentation, let me introduce my group members. My name is Nur Adila binti Bahagia, matrix number AA251087 from Section 2.
My name is Nur Hamaisara binti Muhammad Azizi. My number matrix is AA251670. Lastly, I will pass to Wafa Safia to introduce herself.
My name is Wafa Safia binti Farah Aswad, matrix number AA251896. And I will continue to present about the problem statement in case A and case B. For case A, in engineering, the main risk in urban planning is the mean alignment between the infrastructure capacity and population growth. The population in 2040, T equal to 14, is crucial to predict for water infrastructure management. The constant K is underestimate. The daily water will exceed the capacity of water plant that will lead for failure pressure and decrease of water systematic in urban planning. Next for case B, the problem statement is in engineering formwork must remain in place until the concrete temperature reaches a safe limit of 35 degrees. To prevent thermal shock, a significant temperature gradient between the concrete core and ambient air can induce non-uniform shrinkage and leading the structural cracking and potentially affecting the safety of structure. Next, I will pass to Adila to continue the presentation.
For mathematical derivation for case study A, we use separable and integration method to find the general solution. For separable part, we need to separate a dp and dt. Ensure that all equation has been done separable before integrate. After separable, we need to integrate both sides dp and dt to get the exact general solution. For 1 over p, we use product rule, which is ln p. For ln, we need to move to dt part to ensure that p is single. After the integration, we will get the general solution same as the instruction table. Next, I will pass to Hawa Maisara to explain about the mathematical derivation for case study B.
Next, for the case B, we need use a mathematical derivation. For example, we use a separable and integrate to find a general solution. For example, first we need to separate dt larger and dt small, and then after we separate, we need to integrate to find a general solution. Next, I will pass to my group mates Adila to explain a case A result.
For case A result, firstly, we need to find the constant K. We will use the general solution, which is Pt is equal to Po exponent power Kt. We need to replace with T is equal to 5 based on 5-year trend. Po is equal to 50,000 and Pt is equal to 65,000. That given in the instruction. After put in all the numerical value in the formula, we will find the constant K is equal to 0.052473. For question number 2, we need to find the total population for 2040, which is T is equal to 14. Use the same general solution by replace T is equal to 14 and PO is equal to 50,000, same as the previous calculation. After that, we will get the P14 is equal to 104,235. For last question for case study A, we need to find the total daily water demand in MLD, given that 150 liters per person per day. To determine the total users, we need to total population year 2040 multiply 150 liters. Then we need to divide by 1 million to convert to mega. So we will get the final answer of total water demand is equal to 15.63 MLD. Next, I will pass to Hawa Maisara.
Next, for the case study B, we need to find a cooling constant K using the 2-hour temperature drop. The T is 2 hours and the temperature drop at 10 Celsius. So we need to use a general solution to find a K. For example, we put a TO. TO is 89 Celsius and TS is 33 Celsius into the formula. After we put the TO and TS in the formula, we arrange the TO and TS perfectly and then we will find a K. After that, we need to find a time to reach a safety limit 35 Celsius. We use the same formula, but this time we replace a K with number we get in previous calculation, and then we put the number in the formula like this table. I get a T is 33.88 hours. After that, we need to find time to begin a formword removal. First of all, we need to convert a minute and I get 53 minutes. And then the formword removal start at 8 AM day 1, and after that, after 24 hours, we get a day 2 8 AM, and then we need to 33 minus 24 hours and we get 9 hours, and then 8 AM we need to plus 9 hours and we get at 5 PM, and then don't forget to plus the 53 minutes to get estimate time, and I get a 5:53 PM. So the formword removal time is begin after 5:53 PM for a day 2. Next, I will pass to my groupmate Adila to explain Excel result.
For digital mastery case study A, we use Excel to create a table and graph. To get the left updates in Excel, we need to use the Excel calculation by putting the code formula and then drag it until T is equal to 14. So it will come up with the answer automatically. For graph, we just need to select all the year and all the population growth and click the scatter plot with the smooth line. It will come up with the perfect graph and suitable with the project instructions. For live updates, we need to replace PO from 50,000 to any number to prove that the Excel is dynamic and follow the instructions requirement. So when we replace the PO value, the table and graph will automatically change. Next, I will pass to Hawa Maisara to explain about the digital mastery for case study B.
Next, for the digital mastery case B, I use a Excel. We can see at a table at the left have a initial temperature TO and ambient temperature TS. This temperature is can influence a graph and a table time versus temperature. To get a cooling constant K, we can use a formula in Excel, for example ln, and we can get a K and a T perfectly. Next, we can see the column with the green highlight at 34 hours is the safety limit for our concrete to not have a thermal shock. Next, for the right table, we have a time and temperature. To get a temperature easily, we use a formula EXP from 0, we can drag until 40, use a formula, and then we can get a temperature. Next, for the graph is automatically have when we have a time and temperature. We use a graph scatter with a smooth line. Next, for the live update graph or table, we can change initial temperature 95, and we can see a graph have changed because we use a formula that automatically change if we replace initial temperature. But we can replace a K, and the graph can be changed too. Next, I will pass to my group mate Wafa Safia to explain a conclusion and engineering advice.
For the conclusion, both case A and case B show the Excel results are almost the same as the manual calculation. This proves that the method used is correctly relatable. The small difference only happens because Excel uses more dynamical pace, so it is slightly more accurate. And lastly, for engineering advice or recommendation, for engineering advice, the city council should start early planning to handle the increasing population in 2040. This includes improving the water supply system, sewage system, housing, and other basic infrastructure so the city can support future demand without problems. For case B, the site supervisor must make sure the concrete curing time of about 33.88 hours. It will follow properly before removing the formwork. This is important to avoid cracks caused by sudden temperature change and ensure the structure becomes strong and safe. Overall, proper planning and correct timing are very important in engineering works to make sure everything is safe, efficient, and long-lasting. And that's all from our group. Thank you.